And let's get to the space weather show. It's running a little bit late today, so we're going to be speeding things up. It'll be a high energy and high speed daily space weather show. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. No screwing around. This is the past 24 hours from the closest star here. SDO, the Solar Dynamics Observatory, is the instrument, and that's 171 angstroms, the house favorite wavelength. Don't worry, we'll show you lots more imagery here in the video. And before we show all that imagery, let's take a look at sunspots here. We've had another increase in sunspots, and you can expect another one tomorrow as well. So we're going to have more sunspots appearing than setting on the western limb come tomorrow's video. So expect the sunspot number to continue to rise in the coming 24 hours. That is what's called space weather forecasting. Here's the colorized magnetogram. That's December 18th and 19th to date, just like the SDO continuum that we just showed you. So that's the scenario, and of course, you will hear all over the internet about Fagradalsfjall, the Reykjanes Peninsula eruptions, which look like they're subsiding. So these were a lot more exciting last night. It was about a 4-kilometer long fissure, and now not so much. So things are subsiding. We're not seeing any indications that new dikes are forming here. It looks like things are simmering down at the Reykjanes Peninsula. So you'll see constant updates about this, and Iceland. We're not going to do that because, well, we don't do the same thing as everybody else because I prefer to set trends, not follow fads. So you'll hear all about Iceland. It's not really worth continuing to report on. It's erupted. Most of it's already passed, it looks like. So, and it looks like the town of Grindavik is not going to be encased in lava. So, hoping that doesn't happen, but if it does, hey, there's plenty of time to get out of the way. Raung is also erupting. Mount Raung on East Java, Indonesia. Producing, it looks like about a 5,000-foot ash plume there over Raung. Also, Luatobi on Flores. Okay. That's a new one. Never heard of that one before, but a new avoidance area there. 2 kilometers around the main crater of Luatobi. Merapi's exploding, producing a 15,000-foot ash plume. Tocono's exploding, producing an 11,000-foot ash plume. Popocatépetl exploding, 22,000-foot ash plume. It's a flight level 220 over central Mexico. Headed down to Guatemala, we got Santiaguito and Fuego exploding, flight level 140 from Santiaguito, flight level 160 from Fuego. It's a 16,000-foot ash plume there. Sangay in Ecuador exploding, flight level 210. 21,000-foot ash plume. Continuous emissions from Sabancaya. No indication on the altitude there. Villarrica. No volcanic emissions detected over central Chile. Continuing right along to seismic activity. So here are the past 90 days of seismic activity. We're going to focus on the past 24 hours, citing quakes of a 5 or greater magnitude. Here we go. China had a 5.2. That was early this morning at 1:46 Universal Time. Loyalty Islands had a 5.1 at 2:42. Indonesia had a 5.2 at 2:43. So that's an interesting one. 2 quakes on vastly different locations there. One northwest and one northeast of Australia. Only 1 minute apart. Practically a simulquake. Papua New Guinea also had a 5.1. That was at 6:57 this morning, and continuing up the list, a lull in 5 and greater magnitude quake activity has continued ever since. So getting back to space here is the past 24 hours from Solar Dynamics Observatory, 304 angstroms wavelength, the ionized helium, another classic SDO wavelength, and we've got more new sunspots likely to rise in the east. So it's good times for space weather, wouldn't you say? Here we've added 193 angstroms, and by the way, neither the Bill Maher solar filament, which is this one down here, nor the Lance Armstrong solar filament, which is this one up here, have yet ended civilization. So congratulations on not having civilization end yet. Congratulations on realizing the channel exists. The radio flux is now up to 179 solar flux units. 179. for the 10.7 centimeter radio flux, and you can expect that to continue to tick up as well, along with the sunspot number. After all, it is a proportional data set. There's the 1 year chart. Black line is the radio flux. Red line is the sunspot number. Space Weather Enthusiast dashboard here, expecting unsettled conditions to continue overnight. So we may see some aurora at mid-latitudes. We have some coronal hole high-speed streams as well as CME impacts happening sort of all at once. So space weather is rolling in just about as forecast. See previous daily space weather videos for said forecasts. And next we'll move to Earth's magnetic moment from space. So here are the past 4 hours of our Geospace Magnetosphere movie. It depicts magnetohydrodynamic pressure, and we have currently a highly elevated solar wind velocity. So it's looking like coronal hole high-speed stream impacts, perhaps, but it's tough to tell when the signals are all mixed together. So yeah, could be a case of mixed signals. We'll show you some analysis here momentarily. First, the past 4 hours of Earth's magnetic moment from space. So that's what's happening out to about 12 Earth diameters in terms of magnetohydrodynamic pressure. Here's Earth's magnetic moment from the ground. This depicts magnetic flux density. And by the way, if we see a shift in the magnetic field, we could see sudden geomagnetic storm conditions of significant magnitude happen just all of a sudden. So don't be surprised to see significant geomagnetic storms. So currently KP2 is the situation. But again, if we see a shift in the magnetic field to more favorable conditions for inducing current into the Earth system, we may indeed see some geomagnetic storms. At the moment, not so much. Things are calm. So here's our real-time solar wind as measured by the ACE, showing a very diffuse solar wind there at less than 2 protons per cubic centimeter. Solar wind velocity here quite elevated at 591 kilometers per second. The Discover's got more complete data set. Current conditions are a little bit slower on the solar wind velocity, 542 kilometers per second, but also more diffuse on the solar wind density. It's just dropped down. Oh, all right. The main signal there is more like 1.3 for the past few hours, so quite diffuse and kind of fast. We had the solar wind hovering around 600 kilometers per second there, so two different regimes, two distinctly different regimes. You've got this one here at nearly 600 kilometers per second, and this one down here at more like 500 kilometers per second. So two different streams there showing up and creating sort of a sputtering effect with the incoming solar wind. Also, a new temperature regime here just showed up. That's looking like the slower. So the slower solar wind is also hotter, as you can see there, the plasma temperature, 9.5 times e to the fourth. 9.5 e to the fourth, I should say. So there's our real-time solar wind. Two separate solar wind regimes currently arriving at L1, where the Discover is making its measurements. Next, the GOES magnetometers. And these are fairly smooth. Again, because we don't really have super favorable conditions for geomagnetic storms. The magnetic field is pretty weak, and we don't have a solid negative BZ component in that top frame there. So if we do see a shift in the magnetic fields, we may see geomagnetic storms, in which case you'll see striations, variations, perturbations in the GOES magnetometers. Next, our top view ecliptic plane field plot. One of the best pieces of predictive data you'll find. And let's see what's going on here. Do we have the South Pole? Oh, all right. Yeah, so we may see a strong sunspot here about to rise in the north. I mean, in the southern hemisphere. So you look at the last image here. You see this South Pole current sheet retracting the South Pole sector, the magnetic sector of the heliosphere. Check it out. It's now way over there. That's the last frame. That's the latest image. Only 3 hours old there. And the sector boundary crossing is looking like it's more like 2 days plus out. So that could be an indication that there are some new sunspots here. Let's see. Well, we'll have to look at the fields, actually. So what do we got? We've got South Pole magnetism down there. So this could be additional sunspots about to show up in the northeast, actually. So, and that's what it looks like from the imagery that we're looking at. Here's our line of sight ecliptic plane field plot. We won't leave that on for too long. Here's our line of sight field plot. Here the polar fields are depicted in red and green for south and north respectively. Photosphere magnetism in grayscale, B field in blue. Here is our line of sight coronal hole plot. And we do have some magnetic indecision continuing on in the eastern limb. So once again, the likelihood of a conflagration of sunspots to continue here. We may see sunspot numbers jump up over 200 in the coming couple of days. Don't be surprised to see that. That's not a real forecast. That's just me looking at that data and giving you facts. So that's our line of sight coronal hole field plot. And here is our coronal hole imagery. There is your 211 angstroms from SDO, the Solar Dynamics Observatory. So I suspect we're seeing some high-speed wind from that coronal hole now. And it's just about on time there. No real surprises. We should see that slowly sputter out as time goes on, considering the shape of this coronal hole. So this right here, this is the source of high-speed winds. And then down here, you're seeing it get less defined. So anyway, that's what's going on with coronal holes. Next is sunspots. And sunspot number here now jumping up to about 175. Sunspot number currently about 175. Here's your flare probability monitor and scoreboard. And we don't have any majorly magnetically complex sunspots here. So no super high likelihood for large solar flares. These are fairly simple sunspots. There are a couple that could produce large flares. I would say the biggest players would be 3528 and 3529. Next, sunspots from SDO, and here you go. It's your SDO magnetogram for the past 24 hours. Again, we'll have another uptick in sunspots moving into tomorrow, assuming nothing suddenly degrades. There is the SDO continuum. And how many new sunspots do we have? I don't know. I lost count. I'm not really concerned about it. It's still not at solar maximum. We're expecting that to arrive sometime around September of next year. And oh, and by the way, if anybody's wondering if I think that coronal mass ejections cause volcanoes, the answer is no. Because if they did, there might be some evidence about that. There might be a physical mechanism that could be described as to how that occurs. There's not. So, no, I don't think CME impacts or geomagnetic storms cause volcanoes. If so, I want to know how. Anyway, moving on to energetic particles and solar flares, the ghost proton flux remains at baseline levels. So, nothing exciting going on there. And nothing exciting going on in the X-ray flux either, although the background flux does remain over a C-class level. The background flux right now for the past 24 is something like about a C2. For the background X-ray flux, no major flares over the past 24 hours. And there are the past 24 hours in the spectacular SDO 94 angstroms wavelength. Moving along to a star chart. As to some people, I guess that's considered space weather, so that's what's going on over our head. Skyandtelescope.org can create you a star chart as well. If you want to know what the skies are going to look like above your current situation. We've got Betelgeuse, the largest object visible, the largest single object visible to the naked eye there, just rising over the east-southeastern horizon there. Part of the constellation Orion. Here's our solar system forecast coming next. that's where things are today. That's where things will be in a week as Earth moves into the lonely side of the solar system, the part devoid of gas giants. And it looks like full moon will fall on the 26th? 26th or the 27th, I think. Next, our astronomy photo of the day, and it's a splentacular nebula. This one is illuminated by a super hot, bright blue star. And it is ionizing some of the gas there. Some of the gas is recombining there. So this is actually depicting neutral hydrogen. And there is the likely culprit for the ionization portion of it. The neutral portion there, the part away from the star. That is the astronomy photo of the day, apod.nasa.gov, the astronomy picture of the day. NGC 1499, the California nebula, because it's shaped a bit like California. It is being illuminated by Z Persei. Z Persei is the star there, if you want to go look at it yourself. And yes, it is spelled like the Prime Minister of China. Xi Persei is the star that is illuminating that hydrogen nebula. Continuing on to CMEs. As the sun's blasting out some hydrogen, wouldn't you say? Here are CMEs from yesterday. And let's move on to today's coronal mass ejections. Only 47 frames from today. Things have been pretty calm, actually, here. So no major CMEs. Let's move into... We'll add the C3 here. And let's get a little bit closer there. There are 90 frames. I'm going to let the C3 catch up here a little bit. There we go. Now the C2 is a little bit ahead of the C3 there. C2 on the left, C3 on the right. It's basically just a zoomed out version of the same imagery. There are some differences in the resolution and so on and the contrast, but there you go. C2 and C3. Things have been quite calm in terms of coronal mass ejections over the past 2 days. The past 48 hours, quite calm. We'll also show stereo A to see if we've missed anything. There's stereo A located where that red dot is. And I've got missing imagery here for whatever reason. That is probably my fault. All right, so there's some activity from yesterday morning. Now we're catching up through yesterday evening. And now we're into today. What do you got, stereo A? What do you got? Quite calm in terms of the coronal mass ejection front. Keep in mind, folks, there is a high likelihood of coronal mass ejections. We have some major filaments and quite a few sunspots. So likelihood of CMEs is very high. Continuing on, here's our 24-hour video featuring composite imagery. We've put LASCO C2 and C3 together along with the SDO imagery, as we're known to do. There's a little closer view. And there was a bit of an effect there. I think there was a large solar flare on the opposite side of the sun because there's a weird flashing effect that happens, and that is consistent with large flares not on the Earth side of the solar disk. So you are going to see some plasma motions right in this area, right in there. And that could actually have some CME type earthly directed components there. However, The main event did not occur on the Earth's side of the solar disk. I suspect that's probably some sort of a plasma reverberation happening, not an Earth-directed CME, at least not a direct CME. It might be some kind of a secondary event there. But it certainly looks like something occurred. It's just not on the Earth side of the solar disk. So it happens all the time, folks. Here's the full disk view. Again, you'll see right in this area, you'll see some plasma motions. Right in there. Right there. Right at the end of the video. So that could actually be a CME that is showing up on the imagery now. It could be earthly directed. So if that one would be earthly directed, we'd expect that to arrive sometime before Christmas. So like on the 23rd, we would expect that one to show up. If that is an Earth-directed CME. It's probably too early to tell, but that's my preliminary analysis. Don't like it? Leave a rage comment. Here come filaments next from Cerro Tololo, Chile. Cerro Tololo, Chile. And look at that massive filament in the north. That is the Lance Armstrong. Down there in the southwest, you've got the Bill Maher filament. That's this one down here. This one over here could use a name as well. Not sure if we ought to call that one the George Hincapie. Maybe we ought to let it stabilize first. So that one, some of that ejecta may have already blasted off too, by the way. So a little bit too early to tell. That happened just in the past hour or so. Here's the grayscale imagery, and you can see additional prominences there on the eastern limb. So at least one or two more sunspots likely to rise over the east. These are facts. And before we get to bonus features, let's take a look at the past couple of hours from the GOES 16 SUVI. So again, right in this area, there is certainly some instability happening as we make the video. That could be a coronal mass ejection popping off. It could be a plasma filament collapse. It could be a plasma filament reorientation. It's too early to tell. And here come bonus features. So the first bonus feature is satellite charging. Do we got any? Only minor surface charging there over East Africa and the Middle East. We've also got the GOES electron flux. Coming up off the floor here, here is the 1-year graph of the electron flux from Solon.info. There is the forecast model, NOAA expecting flat levels and then an uptick. I would tend to agree when the coronal hole high-speed stream subsides and so forth. Next, we'll show the layer where it's measured. The F layer of the ionosphere, you got to have it, and here it is. The vibrational frequency of the bridge between Earth and space. We'll also show anomalygram, anomaly in megahertz from a 30-day median. And pardon the pace, we're going to pick it up even faster at this point. And no, I didn't mean the salsa or the hot sauce. I ain't talking salsa and hot sauce. I'm talking about the speed. We're kicking it into overdrive. So there's the latest image. That's 2300 universal time ionogram, 2300 universal time anomalygram. There is the global ionosphere nowcast, the WHAM, the whole atmosphere model, depicting total electron content on the left and maximum usable frequency on the right. The right's for radio operators, the left is for GPS operators. Enough said about that. We'll also show the total electron content. Feel free to pause the video on this frame if you're not familiar with distances in miles. Here's a total electron content forecast for the global scale. It's literally a count of free electrons from your GPS handset down to your up to your it's the electrons from GPS satellite to ground level. There is the latest continuum and latest magnetogram. Here are sunspots. And again, there are additional new ones rising. I think there'll be another one in the northeast. There's a new large one rising in the southeast. And yeah, it's a continued uptick in sunspot number. And just a quick reiteration, if you're mad about each sunspot that forms and or rises, you may want to seek psychiatric help. We hear that they're doing amazing things at mental institutions nowadays. So next we're looking at meteorology. There's Saharan dust. We haven't looked at it for a while. There's Saharan dust there blowing across the Atlantic, tamping down tropical systems, and fertilizing a bunch of islands in the Atlantic Ocean. Anyway, I figured that was a nice little tidbit. Here come the meteorology segments. First, surface winds of the east, jet streams of the east, jet streams of the central world, surface winds of the central world, surface winds of the west, jet streams of the west, clouds and fog over the Americas. There's a low pressure loitering off the coast of California. You might be able to see it in that imagery right there. Here's an even closer view of that. A loitering low, which is what is causing California's weather. So a great view of that counterclockwise rotating northern hemisphere low pressure system. That is pretty sweet. Continuing on to our precipitation type map from Woody.com, we do have some snow falling. Shout out to Smash Staff's mom. And happy Christmas to all of our viewers. Happy Christmas, happy Kwanzaa, happy holidays, happy if you don't like that. I'm sorry that you're so rage-inspired. Please make sure to leave a rage-inspired comment. We got some snow falling in New England and New York as well. That's our precipitation type map. I like it. Don't like it? Leave a rage comment. Here's our weather.gov map, and we've got some flooding coming to Southern California. San Diego is in the crosshairs for some flooding. There is the key. Weather.gov is the place to get your weather alerts if they are lit. Weather.gov. And here comes some forecasts. The GFS 72-hour pressure and precipitation forecast is first. There you go. That's what's going on. Heavy rains coming to Southern California. 72-hour total accumulated precipitation forecast in inches is next. Ta-da! Ta-da! Again, heavy rains there. Those are the totals. Read them and weep. Next, temperature anomaly forecast in degrees Celsius. The same model, the GFS 72-hour. Next, lightning. That is the past, 10 hours, something like that. About 10 hours. And here's a real-time lightning map courtesy of lightningmaps.org. Highly recommend it next time you hear thunder. Right now, it's unlikely you'll hear thunder because things are pretty calm on the lightning front. Although some in the Mediterranean and some in the Atlantic Ocean. By the way, if you enjoy the content, press the like button. Visit our links like smashomash.com. Thanks to everybody who has supported the channel throughout the years. It's only the world's most comprehensive daily space weather content. No big deal. You can also visit our forum if you haven't done that. They'll find many science forums on there, and one of the ones you can check out would be the General Science Forum. Located right here, we've got a Ask a Particle Physicist segment that you can contribute to if you like. You want to ask a particle physicist a segment? Go ahead. Right there is the thread in the General Science Forum. There you go. Otherwise, I'll pick. Actually, I'm going to pick anyway, but if you want to contribute, go ahead. Ask a particle physicist a segment. There he is. The monotone from Minsk. It's Eugene Bagashov. Ask him. Today's featured product is the Smash News Network Least Busted Name of News Premium T-shirt. Hopefully, if you pick one up, you won't look as smug as our model here. And there is the line of products you can get with the Smash News Network Least Busted Name of News. Congratulations on realizing the channel exists. We only provide the most detailed solar imagery you'll find in the known universe. So help us out and check out the subtle graphics of SNN featuring the YouTube URL. SNN, the least busted name in news. You can also help out the channel via the Hemp Lucid shop. Lots of products there. The most popular are the CBD tinctures. HempLucid.com. Save 10% by using the promo code SMASHOMASH10. Yes, SMASHOMASH10. It'll save you 10% on checkout. HempLucid.com. Enter the promo code SMASHOMASH10 or shop via our link conveniently located in the description below this video and on the homepage at SmashoMash.com. You can also find Smash Staff's new dresser. You want to organize your whatevers in style? Well, there's a way to do it. Amazon.com/shop/SmashoMash. Save 13% on the 9-drawer dresser. And if you want to get additional content, alerts and things like that, become a member of the Smash Team at smashomash.com/Smash Team. There's a bronze level, there's a gold level, there's a silver level, there's a bronze. I already said bronze. There's a gold annual paid up subscription level, smashomash.com/Smash Team. And regardless of your stance, make sure you press the like button. Press like. And if you're new to the channel, press subscribe. Hopefully the galaxy isn't going to kill you. Hopefully you're not spooked of the galaxy. I'll just leave it at that. Hopefully you're not spooked of the galaxy. We're going to close out the video with the latest U.S. Doppler radar from radar.weather.gov, if you're wondering. That depicts vertical motion in the air column detected by ground-based Doppler radar systems. So there's the U.S. Doppler map. Here is the clouds and fog map. Here is the water vapor map. And here is the recap. Vertical motion in the air column detected by ground-based Doppler radar systems. Typically used to show precipitation. Space-based systems detecting shortwave radiation at 3.9 micrometers infrared spectra. That'll show you clouds and fog at nighttime, and here is 6.61. That's 6.61 micrometers infrared radiation, the water vapor map. That'll show you water vapor as in all of it. It'll show you the dry air. It'll show you the moist air. And here's me showing you me signing off. Congratulations once again on realizing the channel exists. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. I'm going back to the bunker. Whoa!